Be looking at some angle relationships. So the first one I want to start out with is adjacent angles. So here I have two examples of an adjacent angle and one not an adjacent angle. So here, these are adjacent angles. Red is adjacent to blue and blue is adjacent to green. But red and green are not adjacent to each other. We'll come back to that later. So when it comes to them, there are two properties that make them adjacent, that they share one common side and that they also share vertices. So in this case, red and blue share this line right here, and red and blue share this vertices right here. Blue and green share this line right here, and they share this vertices right here. On the other hand, red and green, they only share a vertice right here, but they do not share a common side. So in this case, red, blue are they are adjacent, and blue, green are adjacent. Now, in this example right here, red and green are not adjacent, but you might ask yourself, don't they share a vertices and they also share a common line? Yes, but they share more than just that. They also share this space right here. They share up all this space right here. So you can't have that. The bare minimum, and you have to have it exactly just one shared line and one vertices. You cannot have all this space right here that they both share. So that's adjacent angles. We're going to look at some linear pairs. So we have two examples here again, one that's not correct and one that is correct. So when it comes to linear pairs, the properties are that they have to both be adjacent angles and that the non-common side, which means the side that they do not share, are opposite of each other. So in this example right here, they're both adjacent. As we said before, they share same vertices and share same side. And they're non-common sides. So in red's case, it's this line, and in green's case, it's this line. They are opposite of each other. So this is a linear pair right here. On the other hand, this one is not a linear pair. They are adjacent, they share same vertices, and they have a common side, but their non-common sides are not opposite of each other. They might be going in opposite directions, but they have to be exactly opposite to each other. So this one's going down more, this one's going more to the left. So these two are not a linear pair. And that is linear. At vertical angles. So I don't really have any like correct or incorrect because it's not that hard to see. So really when it comes to vertical angles, it's when any two lines intersect the opposite angles to each other. So in this case, these two angles right here, those are vertical. These two angles are vertical to each other. These two over here, these two. So it's really any two intersecting lines. And the properties of these two sides is that they're both congruent to each other. So if this were 60, this is also 60. If this were 40, this would also be 40. And it would be the same with all of these. Even if they're perpendicular and at 90 degrees. So if we had these two at 90 degrees, they're congruent, obviously, to each other. So yeah, these are all vertical lines. At complementary angles. So this time we do have a correct and then a wrong. So when it comes to complementary angles, basically they have to equal both the angles 90 degrees. Now, they don't necessarily have to be adjacent like we show here. These two are complementary to each other, and these are also complementary to each other, as we can see from this 90-degree symbol. So this is okay, and this is also okay because they add up to 90 degrees. That's the rule when it comes to complementary angles. On the other hand, this one right here, 50 and 20 do not add up to 90, and it adds up to 70, so these are not complements to each other. In this diagram, we cannot assume that these two angles form a 90-degree angle. We'll be looking at supplementary angles. We would need the symbol. So same with the complementary angles. So this, they don't have to be adjacent, but they have to add up to 180 degrees. Would be incorrect. Also, in this case, you don't need a symbol to show that it's a straight line. You can assume in the diagram that this is a straight line, and so that would be supplementary because these are two adjacent angles and they form a straight line, which is 180 degrees. Also, this is right, just like we said before with complementary. They don't have to be adjacent, but as long as they add up to 180, it's good. In this case, obviously, it does not have to add up to 180, it adds up to 200. So these two would not be supplementary angles, and that is supplementary angles. Crap, is this thing recording? We're looking at some angle relationships. So I'm gonna draw a diagram real quick, and we could. Oh my God! Stop. Can it not? Just. Are you laughing at me? I'm trying my best. Stop. My God. We're going to be looking at some angle relationships. So, okay, the first one we're going to be starting with is the adjacent angle. So, when it comes to the adjacent angle, there's basically one rule you got to follow with that. So, when it comes to that, so we have, crap, yeah, perpendicular angles. So, not perpendicular, they're vertical. Just color them in so you can see them better. So we have this purple angle right here. That doesn't come out well. Let's try a green color. That doesn't come out well either. Alright, let's try a yellow color. So if we look at, why are they all black? Field linear pair because the non-common sides, which are these sides, are opposite of each other, and they go opposite to each other.